Okay, hi everyone, welcome back to this video series on Windows Server 2012. Useful IPv6 information commands. You can use numerous commands to view, verify, and configure the network parameters of Windows Server 2012 or 2. Specifically, you can use the netsh command to set and the route command set, as well as the standard ping and tracer functions. Use the NSTSH command interface to examine and configure IPv6 functionality. The netsh command issued from the command interpreter changes into a network shell NSTSH, where you can configure and view both IPv4 and IPv6 components. Don't forget to use the ever popular route print command to see the Windows Server 2012 or 2 routing tables, IPv4 and IPv6. The other diagnostic commands are still available for IPv4 as well as IPv6 in previous versions of Microsoft operating systems. Ping was the IPv4 command and ping6 was the IPv6 command. This has changed in Windows Server 2012 or 2. Ping works for both IPv4 and IPv6 to test layer 3 connectivity to remote devices. The IPv4 tracer command was tracert6 to IPv6. The command is now tracert for both IPv4 and IPv6, and it will show you every layer 3 IP hop from source to destination. This assumes that all of the administrators from here to there want you to see hops and are not blocking ICMP. It also assumes that there are no IP tunnels while your packets are traversing. You won't see the router hops in the tunnel either. Overall, the consortium of people developing the internet and the internet protocol have tried to make all the changes to communication infrastructures easy to implement. This is a daunting task with many vendors and various infrastructures currently in place. The goal is not to daze and confuse administrators. It's designed to provide maximum flexibility with the greatest functionality. IPv6 is going to provide the needed layer 3 network layer, global addressing layer, logical addressing layer, call it what you like, functionality for the foreseeable future. Subnetting with IPv6. Subnetting with IPv6 is a lot like subnetting with IP4. You need to know how many bits you are you're going to use for the network mask to subnet it correctly. For example, let's say you have an IPv6 prefix of 2001 colon DB8 colon BBCC colon 0000 double colon /53. And you need to set up your network so that your IPv6 addressing scheme can handle 1,500 more subnets. How would you configure this out? How would you figure this out? When determining any number of hosts or subnets, the calculation is 2 to the power 2x. The first power number that is greater than or equal to the number you need is the number that you add to the current network mask. Thus, in the previous question, to get to 1,500 subnets, you would need to determine which 2x is the first one that is greater than or equal to 1,500. If you calculate your powers correctly, 211 equals 2048 is the first one that is greater than or equal to 1,500. So you would add the power 11 to the /53 in the previous address, and you would now use /64 as your network mask. Table 8.8 shows you some of the power numbers for the power of 2. So here you see powers of 2. Summary. Why TCP is the primary protocol in use today, is one of the important topics covered in this chapter. You also learned that the 32-bit IPv4 address is a structured and hierarchical one that is used to identify uniquely every machine on the network. You learned how to determine available IP addresses and implement subnetting. In addition, you learned how the new Layer 3 IPv6 protocol is implemented, including the structure of the IPv6 address. Finally, I discussed the new functionality included in IPv6 addressing, as well as several Windows Server 2012 R2 integration and migration implementations. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.